Welcome students to another episode of Learning with Lafferty. So within this video, I'm going to be talking about three things: metabolizing, nutrition, and body temperature, because all those relate back to what metabolism truly is. So like always, Manee's in the background metabolizing food. He spent the last 6 to 8 hours of the day consuming lots of green veggies, more like seagrass, or if he's living in an aquarium while he rehabs, he would be eating a lot of romaine lettuce and iceberg lettuce. And they eat about 10 to 20% of their body weight. So you think about, if they're about 2,000 pounds, that's a lot of metabolizing that has to happen. But we're going to be looking at the process within this chapter of truly what metabolizing is. Now, this video is going to be a little bit more complex than some of my other videos, and it does bring us back to the basics of the chemistry chapter. So I'm going to go ahead and mention, like I did in a prior video and several prior videos, of talking about the four main elements that makes up 90% of our body weight. That would be oxygen, carbon, hydrogen, and nitrogen. So we do have obviously the other 4%, okay, that we'll be talking about today, of the things that we consume, such as vitamins and minerals. Okay, we would have talked about some of these when I talked about in the chemistry chapter of your electrolytes, these ions, okay, things that we definitely need to consume. But when you're thinking about those four elements, definitely the importance of course, oxygen needs to be the highest in our body, carbon is next, hydrogen is next, and nitrogen is last. Okay, so it's in that order, but our body is going to always be using them. So definitely don't forget about, with chemistry, the basic of water. Okay, H2O. Okay, so if you know what those letters stand for, that is important. Okay, so oxygen and hydrogen. Okay, so every time we consume water, then we definitely are consuming some hydrogen. Okay, so definitely going back and refreshing your memory. I'm not going to spend time within this video, but definitely make sure you go back and understand what pH is and the importance of having our pH at that little bit more acidic, because water itself is considered to be neutral. Okay, remember, our blood within our body needs to be more on the basic side. So what is metabolize? Okay, so metabolism, that word literally means a series of chemical reactions necessary from the use of raw materials. So think about all those foods that we are consuming, either be healthy or non-healthy. Now I want to talk about here in a few minutes carbohydrates and what they are. Okay, and again, I would have talked about this way back, but it is important to kind of put that stuff back in our memory, because we definitely need to understand it. So we'll talk about carbohydrates, what they are. The second thing that we consume are going to be these fats, okay, aka lipids. And then lastly are the proteins, amino acids. Okay, so remember, amino acids are the little individual pieces that are built together to make proteins. Now, these chemical reactions, remember, have to happen within the cell. So all these processes that I would have spoken about passive and active transporting things across that membrane, things have to come in the cell for that to occur. Now let's do some definition of the word metabolism, of two different parts of metabolism. First, there's catabolism. Okay, so I think of a cat. If you have cats, I have lots of them. They can be very sweet sometimes, and then they can have little attitudes other times. Okay, and they'll come and knock things off. Okay, manatees are sweet. I don't think manatees would do that. Of course, that'd be kind of weird if a manatee was sitting on your countertop. I would love that though. But if they did, then they came and knocked something off. That knocking something off is taking something that's larger and breaking it into more simple components. Okay, so catabolism, definition-wise, is the breakdown of something complex as far as compounds. Okay, there's that word. Definitely, if you didn't understand, compounds versus molecules. Okay, so again, compounds, we think about with that being, one type of element that it will eventually bond with another element to join something. Where molecules are going to be a couple different types of elements that come together and bond, because bonding is very important. Again, different types of elements coming and bonding with a different type of element. Okay, again, compounds are the same thing. So like oxygen and oxygen, when it's bonded together, that would be two oxygens, or hydrogen coming together. But then we think about these complexes. Of course, water is H2O. Okay, nitrogen. Okay, N2. We think of course, glucose is carbon, hydrogen, and oxygen. Okay, it's crazy to think that's really what glucose is. Table sugar, okay, is going to be converted into glucose. And then lastly, we think of table salt would be salt, okay, sodium is going to be combining with chloride, okay, those two joining together. So that is definitely important to be thinking about. Now, catabolism includes digestion. So when I want to talk about the digestion of the different foods that we eat into smaller molecules. Okay, so think about all the mechanical processes that would have broken down the food small enough. Okay, so that's the first part of we think about catabolism. And then that releases energy from those molecules within the cell. That is very important to be thinking about. Now, the second type of that process of metabolizing or metabolism is going to be the building of simpler substances into nutrient storage compounds. Okay, structural materials and even things that are functional as far as these molecules, such as enzymes and transporters. Okay, so you think about, again, knowing what an enzyme is. All an enzyme is a catalyst. Okay, so think about catalyst helps to speed up the process of things being broken down. Okay, so anabolism is about, again, helping those nutrients, the storage compounds, helping us be structurally strong throughout the cell components of our body. Of course, remember, cells come together to make tissues that come together to make organs. Okay, so kind of going back and forth and remembering that aspect is important. But they also help to make these enzymes that our body needs to then break things down. Okay, so it's a back and forth that our body in that homeostasis process is always going to do. Now remember, a chemical bond, so when two things come together, so oxygen, or oxygen and carbon, or hydrogen, oxygen, when they bond and have a chemical bond, that series of catabalistic, okay, type of reactions also is called cellular respiration. Okay, so don't think of necessarily us breathing, okay, that pulmonary respiration, but this is at a cellular level. And that transfers some of that energy, the things that we have consumed, into potential energy in the nutrients to be bonds of ATP. So adenotriphosphate. Okay, and again, back to kind of that basic chemistry. That's what our cell needs. That's the type of fuel. So it'd be kind of like trying to put diesel in a gasoline car. Don't do that, okay? Or vice versa, try to put gasoline in a diesel car. That vehicle is not going to know what to do and actually will add damage to the energy source of the engine, okay? So for us, we're putting in the right nutrients is also going to make sure that, again, the saying is you are what you eat is very, very true. So think about if you eat a lot of junk food, a lot of heavy food, then how you feel kind of tired and sluggish, then our cells are having to convert that into something it can actually use. Okay, or if you give it too much, think of sugar, too much glucose, and you have too much energy. We think of a sugar high, but also think of that sugar low. Okay, our body has to do something with the things that we consume. So those reactions begin with glucose. Okay, we have to have glucose constantly. Then we have the fatty acids, aka the lipids, and not as much, but you can have some converting at the amino acids, okay, the protein side of it. So let's start a little bit, talk about glucose, so that simple sugar that is the principal source for the cells. Let's talk about what glucose is. That's important. So glucose falls under the category of carbohydrates. Okay, so again, healthy diets we think about, we need an abundance of complex carbohydrates, whereas simple sugars are kept to a minimum. So simple sugars are monosaccharides. Okay, so glucose falls under that. Then we have fruit sugars, okay, fructose. And then next you're going to get into the disaccharides. Okay, disaccharides are sucrose, which is true table sugar, and milk sugars would be lactose. Okay, now simple sugars are a source of very fast energy because they are metabolized very quickly. Okay, so sometimes like the moment it touches your mouth, it's starting to metabolize. Now, however, they do boost that pancreas insulin output, and as a result, they can cause your blood glucose levels to rise and fall very rapidly. So hence up and then down. It's healthier for us to maintain more of a steady glucose level, which ranges anywhere from about 85 to 125 throughout the day. Okay, and again, textbooks will vary. Obviously, in tests and stuff, you would see kind of that normal range within the test, and think of hyper and hypo below that. Okay, and usually it's pretty extreme when they talk about it. So if it's 80 to 100 on a test, and think about, okay, 60 would be the lower, and then 120 would be the higher. Okay, as far as extremities of hyper and hypo. Now you get what is called a glycemic effect, is measured how rapidly a particular food rises or changes the blood glucose levels, and then stimulates our pancreas to secrete its insulin. Now this effect is generally very low when we eat things like whole grains and fruits and vegetables, dairy products, and high it's very high on that side when we think about refined sugars. Okay, so we think of the white grains. Okay, so that's why you need more of that when they talk about whole grains, things like that. Now that glycemic effect of food also depends on when it's eaten during the day. So we do have that up and down roller coaster of when certain enzymes are released in higher numbers or lower numbers throughout that circadian rhythm that we have throughout the day. And it does vary from person to person. Now, complex carbohydrates are the polys. Okay, so the polysaccharides, the examples would be such as starches. Okay, so starches would find in our grains. Okay, like beans. Okay, potatoes would be examples of that. Even rice. Okay, would fall under the starches, but also fibers. Okay, so we think about structures that come from a plant based. Okay, that cellulose. That would help to, again, the non-digestible fibers also too, to help kind of, you think about cleaning out that excess sugar. Now, fiber itself cannot be used for energy, so we can't convert it to APT, but it adds the bulk to our stool, okay, our feces, and helps to promote and literally takes in those toxins and waste as it's leaving our body. So that's what's really good. You think of the commercials of Metamucil, okay, that are very, very helpful because it's picking up that excess glucose along the way to get it out of our body. It also helps to slow down the digestion, okay, and other absorption also on that side of these extra carbohydrates, the simple sugars that we don't need too much glucose. Now, by doing that, it helps in weight control by promoting that sense of fullness. Okay, so then it goes back to the brain and it tells you those hormones I would have talked about in the digestion that, okay, I'm full, I don't need to add anything else to the body. So it helps to prevent somewhat some of the senseless eating that we're bored, we think we're hungry when we're really not hungry or don't need to take any more calories in. Now we'll get to the fats and aka lipids and proteins here in a minute, but let me kind of backtrack now that you understand what a carbohydrate is. Now we think about carbohydrates also within our diet. We need to have anywhere from 55 to 60% of a structured diet within that range, far as what the FDA talks about or the USDA talks about. That's kind of where we need to be. Okay, so about a little more than half of our diet does need to be carbohydrates, but we want it to be more of those complex carbohydrates per se. Okay, not the simple table sugar. Okay, it's not always the best thing when we think about it. Now, when we think about this cellular respiration, okay, what did that mean? Okay, there's two different phases of cellular respiration. The first phase is glucose metabolizing, okay, of catabolism. Okay, so catabolism happens first without oxygen. Okay, so no oxygen is needed, and when it gets inside of the cell, this is happening within the cytoplasm. So when we eat food, it is transferred into the cell by the use of insulin. Because remember, glucose cannot get inside the cell to metabolize unless we have enough insulin, like putting that glucose in the backpack, and insulin carries it into the cell. Okay, so it needs what they call facilitated diffusion across that membrane. Now, the first step in the breakdown of glucose that does not require oxygen is also called anaerobic. Okay, so anaerobic is the phase of catabolism that is also known as glucolysis. Okay, so glucolysis occurs only within that cytoplasm. So again, where the organelles are going to live. But if you remember anything about how the cells work, it needs to get to the mitochondria, because that glucose needs to get there, is where that the ATP, the type of fuel that the body needs, is going to occur. So each glucose molecule, when it gets in, yields enough energy by that process to produce 2 molecules of ATP. But I don't know about you, I would rather have 20 versus 2 when we think about numbers of things. Okay, so if I have $2 in my bank account, I can't buy as much as I have $20 in my bank account. So at least it starts the process of giving our body some energy, potential energy, these molecules that it needs. So like little batteries, so 2 batteries is better than none, but we definitely think, okay, 20 is better than 2. So at least gets that process started in the cytoplasm. So when that process ends with that formation of a product, a byproduct. So remember, within the body that nothing is wasted, okay, but there's always stuff, there's always waste that is left over. So when the body is using, there's always, when you consume something and use something in the chemical world, there's always going to be a byproduct. Okay, and that byproduct is called pyruvate. So pyruvate is the byproduct of, again, that glucose molecule getting in each one and making 2 ATPs. Now that molecule then is further metabolized into the next phase of cellular respiration, which occurs in the mitochondria. Okay, so now we've gone inside of the mitochondria. That does require an oxygen molecule. Okay, so think about that. Okay, we think about what a mitochondria is, the powerhouse, but it needs oxygen to do its job. So view oxygen like at a factory, getting in the energy that the factory needs to run that line to make the product that they're making. So that would be oxygen in the way of our body. Think about muscle cells when they're by that need to make a lot of energy. So think about your heart or your skeletal muscles, for example. At the start of exercise or something very, very intense, this pyruvate cannot be metabolized fast enough. Okay, then it accumulates within the cell. So that pyruvate is then converted into a product called lactate. And lactate, we think of lactic acid, okay, so lactate is accumulated in the cell and can spill over into the blood, okay. Now other tissues, especially the heart, can take up that lactate and then convert it back to that product of pyruvate, and then that can help with further catabolism. So you can kind of see, even though we have waste sometimes, it seems like within our body is really good at recycling and to using the things that it is given. Okay, so we talked about the anaerobic is producing 2. Once that glucose gets into the mitochondria, things really can magnify very quickly, okay, because it has the oxygen that it needs. Now, on average, cells are able to form 30 molecules of ATP per glucose molecule. Now, ATP, again, might vary depending upon the type of tissue throughout our body, the type of cell, okay, that needs and how much energy they're going to need. Now, during this phase of aerobic step of cellular respiration, the mitochondria can produce and will produce carbon dioxide and water. Now, because oxygen is required in this last step, cellular respiration is described sometimes as nutrient oxidation. Now, the enzymes, remember, that are required in this catalyst and all of these metabolic reactions are the vitamins and minerals, the things that we are consuming. Hence, your body has a lot of what it needs, but obviously if you stop eating, then it's going to get all the little pieces that it needs to build the puzzle of assembling things to get the fuel that our body is going to need. Now, in this process of cellular respiration, a lot of it's dependent truly on how much glucose we're getting. Okay, again, mono, di, and polysaccharides. But we can have fatty acids, aka lipids, that I'll talk about here next, that can be used. And then we'll look at amino acids. So let's talk about what lipids are, these fatty acids. Now within our diet, we need about 30% or less. Okay, so that's kind of, again, kind of this guideline out of 100. Okay, so we have 55 to 60, about 30% of the things we're consuming need to be on the fat side of it. Now again, we think about fats, again, moderate amounts of fats are necessary for our health because they give the energy. They also make up literally the cellular plasma membrane that our cells need. And they also, of course, add taste, and it's why we like adding fats to a lot of our foods. But not all fats are the same. Not all lipids are the same. Now, the healthiness of them are the characteristics depending upon 3 different types of fatty acids. Okay, so when you think fatty acids, think of lipids. Now, there's essential fatty acids. Okay, while any fatty acid provides energy, some of the cellular components require very precise fatty acids. Now, most fatty acids will vary because they can be synthesized within the body cells, but there are a lot of these that we have to consume. Now, the essential fatty acids must be taken in as food, so we have to, hence the word essentials itself. Now, these are coming from like vegetable oils, okay, so think of vegetables, and again, they're primarily used in our body also to make these PGs, proteoglycans, among some of the other functions such as making that cellular plasma membrane. Now, the other type of essential oils, okay, we think of fatty acids, are going to be found in, fatty fish, shellfish, dark green leafy vegetables, flax seeds, walnuts, and of course the oils that we can get from them. Now, fatty acids then we think about can also then be converted into 2 other more subcategories, such as saturated and unsaturated fats. Now, the fatty acid and the saturated fats have more hydrogen as far as their atoms. So you think about back to that pH scale, because they have no double bond between the carbon and they're more saturated in the hydrogen itself. Now, we think about saturated fats come from animal sources and are solid at room temperature, such as butter and lard. But also in this group, we think of tropical oils, such as coconut oil and palm oil. Now, unsaturated fats are going to be derived from plants. So they're liquid at room temperature. Okay, they're generally found in oils such as corn oil, peanut, olive oil, canola oils. These fatty acids have 1 or more double carbon, which excludes hydrogen. An unsaturated fat can also be called a monounsaturated. Okay, think of one, okay, when you think of that. Now, most unsaturated fats, since they're liquid, they can spoil. Okay, so a lot of commercial food manufacturers have used fats that are artificially saturated to extend their shelf life and improve their consistencies. Now, evidence has shown that a diet of these trans fatty acids are these more harmful than the natural saturated fats. Can raise our LDLs, okay, so we think of the lipid protein of cholesterol, and lower the levels of healthy HDLs. Okay, so you think of L for lousy, H for healthy, cholesterol. Now, just like with glucose, these fatty acids break down completely to yield the ATP that our body needs. Now, remember, with ATP, we also end up with more water, and we also end up with more carbon dioxide. Now, the last type of foods we consume are our proteins, or amino acids. So let's talk about those next. So amino acids are the building blocks to make the proteins that our body needs. Now, we have 20 different types of amino acids to build these proteins, and the metabolic reactions can synthesize 11 of them within our body. Now, those 11 amino acids are described as non-essential because the body, because they need not be taken in as food. Our body can actually make them. But then you think about the other ones, okay, at least the other 9 that our body needs to take in because it cannot metabolically make those amino acids. Now, those are called essential amino acids. Now, one thing very precisely important to understand about proteins, unlike carbohydrates and fats that can be stored within our body, these cannot be stored in special reserves when the body needs them. So proteins have to be consumed on a regular basis and obtain the right amino acids so that we can have the bonds that will come together. Because remember, amino acids are little tiny pieces that are put in the correct order to make the proteins. Okay, so think about that. We need at least 9 different types of these little Lego pieces. Our body cannot make itself in order to make the things that our body needs. Now, most plant proteins are lacking one or more of those essential acids. So people that are in a very strict, if you're a true vegan, or in a very true vegetarian diet, you've got to combine foods that add in that extra element that is needed. Now, proteins are considered to be either complete or incomplete. A complete protein contains all those amino acids. Now, complete proteins are foods that are found in animal sources. So we think of meats and eggs and dairy products. Now, incomplete proteins are those that do not contain all of those essential acids that our body needs. And these proteins include vegetable proteins, such as nuts and grains, and think of legumes, which are going to be beans and rice, with grains, that combining of the two, such as rice and corn and wheat, will get all those essential amino acids that we need. So it's a really good idea. That's why we need a variety when we eat each day, of combining 2 foods, such as maybe beans and grains, to get all those amino acids that our body needs, not just from one source, but from 2 or more sources. Now, one thing important when we think of amino acids is they must lose their nitro group, needs to be removed. Now, that removal process happens at the liver, and that's where the nitro group then is formed into urea. That combines with carbon dioxide, and that is, of course, eliminated through our use of our kidneys in the urinary chapter that I want to talk about. So you can see, of course, all of that food that's going to those vital organs, such as your liver and kidneys and the small intestine, all those 3 there play that role of elimination, getting rid of the things that we don't need, but also if it needs to keep it and go around the body again. So chemical reactions, when you think about the word metabolism, if my metabolism is slow or my metabolism is fast, is all truly depending upon what your cells are doing internally with the chemical reactions from the food that we give it to convert that food into the fuel source of ATP that our body is needing, those little batteries that our body needs in each individual cell to be able to do the job of working. Now, metabolism then is truly about the ins and the outs within that cell. So again, of course, we think of the ins and the outs of the foods that we also consume. Now, remember that atoms are not created and destroyed in these chemical reactions. That's important, okay? They're always there, okay? So I'll give you an example. Let's say that you lost, let's say, 50 pounds of fat, adipose tissue within your body, okay? Where did all that fat go to? So you ever wonder that when you lose weight, like what happened to the fat? Now, to truly really understand that, of course there's a lot more, but the Cliff Note version is we have to follow what happened to the carbon, the oxygen, and the hydrogen molecules that made up that fat, okay, that lipid, and as they were catabolized, they were broken down from the more complex to the smaller. Now, the atoms are not burned or lost, but they are converted into either carbon dioxide and water. Okay, so actually think about it, we actually breathed out that carbon dioxide if our body didn't use it for bicarbonate, or we excrete it through the water that we either sweat out just a little bit, or obviously we're peeing out most of it, a little bit, of course, within our digestive system. So again, we're made out of 4 main things, okay? What we're putting into it, our body then will figure out what it needs to keep and what it needs to excrete through the use of carbon dioxide, hydrogen, and then, of course, water. And of course, we think about the nitrogen kind of goes back to the urine side of our excretion. Now, metabolic rate. Okay, so I've talked a lot here about what metabolism is, but let's talk about the rate of like the generalness of it. by no means am I getting into a true nutrition class. We're doing kind of the basic side of it, so at least we have a basic understanding of what nutrients are all about. Now, so when we think of metabolic rate, that is referring to the rate at which cellular respiration metabolizes the nutrients that we need to produce the ATP. So we think about if it's happening slow, we have a slow metabolism. If it's happening too fast, we have a fast metabolism. Now, the body makes ATP on demand, and that metabolic rate relies on and relates back to the energy requirements that we precisely need. And of course, we know it's affected by the size of our body, age, and if we're male or female, and activity. Hormones do play a role within that. Now, the metabolic rate is high in children and adolescents, but of course will decrease as we age. Now, the basal type of metabolic rate is the amount of energy needed to maintain life functions while the body is at rest. Okay, you're not doing anything, you're sitting on the couch. Okay, now so your BMR, your basal metabolic rate, is the energy you expend each day simply to stay alive. Okay, so of course it would be that magical number. Now, any activity we perform, even if you tap your foot, move your hands like I am, increases the energy that you're using, okay? That's above what your BMR is. Of course, we think about that calories, so how many calories we need in will vary from person to person, even though we generally have, 2,000 calories a day is, or 1,200 calories is what you need if you're trying to lose weight, depending upon your age and your weight to begin with, okay? But all those calories relate back to is the energy that's needed to maintain your life and how much energy that each cell in your body will need. Now, in addition to carbohydrates, fats, and proteins, our body requires different minerals and vitamins to sustain life. Now, minerals are chemical elements needed for your body structure, fluid balance, and other activities such as muscle contraction, nerve impulsing, and even blood clotting. Now, definitely important to understand minerals. I'm going to name a lot of them for you so you have an idea of what a mineral is, but you would have heard about these when we talked about elements and I talked about ions. Okay, so calcium and phosphate and sodium and potassium and chloride and iron and iodine and magnesium, copper, okay, zinc. Okay, so all those different minerals, it's important to understand that their job is to, again, help us with maintaining activities throughout our body. Okay, so definitely, look through the tables in your textbook and understand the functions of each one of these individual minerals, where we're getting them from, so what type of foods would we need to consume, but even better would understand, okay, the pathologies of these, okay, the result of if I'm not getting enough calcium, okay, some of the diseases. Now, vitamins, on the other hand, are more complex substances needed in very smaller quantities, okay. Vitamins are part of the enzymes and other substances essential for that metabolizing, because remember, we have to have these little pieces to even have this process to happen. Now, water-soluble vitamins are the B and vitamin C type of vitamins. Okay, these are not stored, okay, and must be taken in regularly with food. So B and C, okay, we need to get those in our body. Now, the fat-soluble vitamins are A, D, E, and K. Now, these vitamins are kept and reserved in our fatty tissues. Excess intake of fat-soluble vitamins can lead to more of a toxicity within our body. So, of course, like I said, you got A's and your B's, definitely understanding the functioning of each of these, where we're getting them from, and, of course, the deficiencies, the hypos from them. And then you get into, of course, the C's, the D's, the E's, and the K vitamins. Again, kind of the same thing of what they're making within their body. But remember, we need to consume them, but we have to be careful of not getting too much of these vitamins. Now, some of these vitamins can be what they call antioxidants, and an antioxidant is helping to defend any harmful effects. These free radicals that come within our body, UV light, pollutions, all of that. They're very helpful, again, and reacting to stabilize those free agents and minimize their effects on the harms on our healthy cells within our body. Now, again, guidelines, the USDA dietary guidelines, I kind of mentioned that earlier. Again, 55 to 60% should come from carbohydrates. Again, more complex would be better. Then we get to fats, 30%, and of course, then you get into the protein aspect of it. So again, it kind of varies a little bit. The newest guidelines begin in 2021 and to currently, and I'm sure they usually change every 5 to 10 years. But definitely making sure that you're getting a colorful plate. Okay, so fruits and vegetables and proteins and dairies and grains and oils, all that stuff you can see plays a role into what our metabolism truly is going to be, because metabolism comes back to the chemical reactions that make the ATP that we need to keep us alive. Now, one thing I will mention when we think about alcohol, that it is not a nutritional benefit. It does yield some energy though, but is not considered a nutrient because it doesn't have a good byproduct at the end. Okay, so nutrients coming in usually have something our body can use once it's been used, the waste byproduct that our body can use somehow. Actually, alcohol interferes with metabolism and contributes, we know, to a variety of diseases. This chapter I'm also going to mention a little bit that relates a little bit back to the integumentary system when we think about heat, okay, body temperature, thermoregulation. So heat is a very important byproduct of all these chemical reactions that we talked about within our cells. Heat is always being lost through the variety of outlets, okay? While the amount of, heat gain and loss consistently changes, body temperature, though, is regulated by a special thing within our brain called the hypothalamus, okay? So remember that feedback loop of homeostasis. So about 15 to 20% of heat lost occurs within the respiratory system, so breathing out and breathing in, okay, when we're going to the bathroom, okay, when we're defecating, okay, but 80% of it occurs through the integumentary system of your skin. So again, most of it happens at the skin, but then we can have some in breathing and the other elimination parts of our body. Now, we do have 4 different types of, losses when we think about heat. We think of radiation. That is where heat is transferred from one source through those heat waves and rays. Radiation does not require contact with the heat source and the heat receiver. Okay, so right now would be a good example when I'm actually making this video of snow. Okay, and the coldness of it, snow comes in, doesn't necessarily physically, but that wind blowing in is, of course, going to have heat radiate away. So think of a radiator heat, okay? So if you ever have a radiator heat system within your house and how the heat's pulled away from that device, okay, that is what it's talking about. Now, convection is where heat is transferred by the movement of cooler air through contacting the medium. So we think of like wind blowing, that's really cool. The air around our skin puts it in motion. So we have that fan going and blowing on us, or even the layers of heat air next to us is an example of the transfer of heat from muscle tissue to circulating blood within our body. Okay, so that's convection. Now, evaporation, this one you kind of think of the other side of heat loss of it's too hot. Okay, so this is where heat is lost in the process of exchanging liquid to a vapor state, such as like when we sweat. And then lastly, conduction is when we literally are as a warm object as transferring heat to a cooler substance, okay, such as like you're running a fever, you lay an ice pack on you, and then the heat is transferred from your body to that cooler source. Now, it's important, obviously, we don't want to lose too much heat, especially, obviously, if we get into newborns. The younger we are, we can't regulate via our hypothalamus, the heat exchange that's happening. So definitely we know that, children and babies are going to lose it a lot more quicker than adults. We think about the core part of our body wants to maintain the main organs. So that's why it's important to keep your head, but keep your arms and legs covered at all times when it's really cold, and not having it too bundled up when it's too hot, due to the fact that our body wants to maintain homeostasis within the core part of our body. Now, temperature regulation truly happens at the hypothalamus. Okay, there's a control center there. Again, that's the area located just above the pituitary gland that I would have talked about under the chapter of the integumentary system. Definitely understand that thermoregulation is about these temperature receivers, okay, called receptor cells throughout our body, but mostly within our skin, and even within the hypothalamus itself, that sends signals back and forth to our muscles and our blood vessels to constrict and dilate, or us to move, like shiver when we're cold, to generate more heat to keep more homeostasis. Now, normal body temperature runs anywhere from 97 to 100. And again, within that range, it's a set point that our hypothalamus has within that range. Now, the 101 is kind of the generic term for, then we have a fever. Okay, that's outside of that normal range of the Fahrenheit scale, that when we would have a hyperness to our body. So anything that's above 100, 101 to be precise, considered fever. Anything below 97, as far as the core part of our body, is considered to be hypo. Now, if our body is too cold, okay, those cold conditions, the hypo, there's going to be a set point that's going to change within our hypothalamus. It's going to cause our blood vessels to constrict throughout our skin to reduce that heat loss. Our skeletal muscles then shiver. Okay, we're actually going to have a rhythmic contraction that results in more metabolic heat production. So the hypothalamus then notifies the cerebral cortex to maintain the body temperature in the core, so we don't go into shock. Now, the opposite of that, of course, is, hyper. We think of hyperthermia instead of hypothermia. This is where, of course, we go above that set point. Then that signals the hypothalamus, which causes the cutaneous blood vessels to dilate. So that will increase the blood flow, that will promote heat loss. Okay, the hypothalamus then, of course, stimulates, such as the sweat glands. Of course, we're going to start to sweat. And the rate of heat loss through evaporation depends upon the surrounding air, okay, as far as cooling us down. Now, that word fever, when we think of hyper, okay, it's a condition when the body temperature is higher than normal. This is when we get into thinking about, okay, what caused the fever? Is it an itis? Is it a true immune response? And I would have talked about that under the information of the lymphatic system and that response. But remember, when white blood cells consume things in our body, then when the chemicals that are released, when a white blood cells eat something that is trying to attack the body, such as a virus, there's pyrogens that are released that trigger the hypothalamus to increase the body temperature. Now, when we have any type of non-immune response, it can be an injury or some type of damage to the central nervous system, even emotional aspect of it. There's still a lot that is unknown of what triggered the hypothalamus to change. Sometimes it can be part of the autonomic nervous system, the fight or flight system, that is causing that response, just to make for sure there's not some type of virus or infection within our body. Now, in this last part of this video, I'm going to talk about some disorders that relate to your metabolism, nutrition, and then also relate to heat disorders. So on the nutritional side, definitely be thinking about things such as food allergies. Some of that can come from the enzymes that we're eating that our white blood cells overreact. And they've kind of changed their liking of the things that we are consuming, or we're missing certain enzymes within our body to break down those foods. So our body's reaction is just to kind of go into overdrive with the immune response. So the next disease we think about is malnutrition. If any vital nutrient is missing from our diet, then the body will suffer from malnutrition. Now, sometimes we think of someone that's, malnutritioned. We think about, that they're not able to eat. But malnutrition can also come from eating too many of the wrong foods. Okay, so eating too many carbohydrates, eating too many lipids, eating too many proteins. Too much of a good thing also is a problem too. Now, we think about when we do that, then the factors that contribute to that can come from, of course, obviously, we think about not having access to the proper foods, or not being able to afford a well-rounded diet. So problems, of course, that can come from malnutrition. We can have, swelling throughout our body, edema. We can have skin and tegumentary problems. A big problem that you look for is, of course, fatty liver disease, which, of course, they contribute to things such as diarrhea. The muscles start to waste away, and then a lot of times we will get problems such as anemia. Now, the heat-associated disorders would be, of course, the thermoregulation of hyperthermia. Okay, so we think about conditions where we would have heat cramps and then heat exhaustion, and then, of course, the worst of those would be heat stroke. And again, that's where the body temperature is above 104. That's when you get into, of course, the danger aspect of it causing the brain to start shutting down. And then, of course, the other side of it during cold weather would be, of course, hypothermia. That's, of course, you're going to get uncontrolled shivering, lack of coordination, and, of course, then you get problems with heart and respiratory levels start to decrease. Of course, the big one we think about, of course, arms and legs especially. We think about it when we're exposed to cold, particularly moist cold. We think about frostbite, okay, and that's where we have permanent damage. Of course, then we think of that turns into gangrene, and then gangrene turns into necrosis, and that's when those cells are completely dead within that area. So hopefully within this video, I've helped you to be like a manatee, to go out and get you something to eat. Probably need to eat more than he eats because they are obviously on the vegetarian side. So we definitely need to make sure our bodies are a lot different and built different than manatees. We definitely need to get the carbohydrates and the fatty acids within our body. So go have you a well-rounded meal. Get your carbohydrates, your fats, and your proteins this day, and I will look forward to seeing you within the next video.